Today we are going to talk about this robot. It's called a self-balancing robot. As you can see, this robot, it's small robot mainly. It can come in different size. Mainly what features this robot is that it has two wheels and it can balance itself, and also it can move forward, backward, turn, go anywhere. So some people may maybe say it as a toy, but in engineering it's really a good product for engineering or to learn control. Okay. First we will talk about the hardware. So as you can see here we have two wheels, of course, two rubber wheels to have a good friction with the ground. Okay, so we need to take care about these things if we want to build our self-balanced robot. Here we have a geared DC motor, so it's a DC motor with a gearbox to have a certain RPM. And its back, as you can see here, we have this black part, additional part mounted with the motor. So this is the encoder. So mainly the encoder here is mounted with the DC motor, and it helps us to measure the speed or the RPM or the distance the robot is moving. Okay, so as you can see here we have a bracket that mount the DC motor with the wheel to the body. Okay, the body is a piece of metal where we have some spacers and connectors here. In the middle we have mainly those are two boards, not just one board. The lower board, as you can see here, is the Arduino Uno board, or any microcontroller can be. Here we are using the Arduino Uno. Okay, as you can see from inside here, the connector to program it, and its pins. Okay, as you can see here, are connected to the upper board. The upper board here is a voltage regulator board. Okay, and we have on above or on it we have three modules mainly. One is the motor drive. So motor drive is used to control the motion of the motors from the Arduino. So motor drive gets data or information from the Arduino and send information or orders to the motor to control their direction and their speed. In addition, we have a Bluetooth module. This Bluetooth module can be used if you want to control this robot via Bluetooth, where there is a special software or application on the cell phone. Lastly, which is the most important, which is the sensor of the main sensor inside this robot, which is inside. It's the inertia sensor, or we call it MPU, which with this sensor is mainly used to find acceleration, gyroscope, okay, and it can help us to know where the robot and how much it tilts, how to calibrate it, and to measure the angle. Lastly, it's the power, or the three batteries we have here, which power our system. So as you can see, they are coming through to here through this jack. Okay, here we have the power button to power our system, and it can start running. So this robot can work in two modes: stand-alone modes, which means you can just power it and it will balance itself. Okay, or it can work with a control mode where you connect to Bluetooth and you control like your phone is a joystick, and you are controlling like a toy or a car, where it can move, rotate, stop, etc. So as you can see here, I will turn on the light. Okay, I will try to start at a balanced position. Okay, as you can see now, it just started. So as you can see, the robot is trying to balance itself by keep moving forward, backward. And this is considered as a controlled system, a stable control system, since already it's moving forward, backward many times. But this is normal to reject or to compensate for the weight of the robot if it's falling this way or back. Now I can put some disturbance. For example, if I put little push, okay, it will start to reject my push to stay balanced. Okay. So as you can see, the robot does not move forward, backward, it just tries to balance itself. If you want to move it forward, backward, we need to use the application, or of course you can do it in programming if you want to make it move for certain time, certain speed, at certain speed, certain distance. Okay.
Okay.
So this is
what if we turn off it falls down.
Okay, if it falls down, okay, for example, it turn off. Okay.
No, if I turn off the battery,
Okay.
it falls down.
Yes, hello. No,
Let's see.
for example, if I turn off, okay.
Can it stand by itself or no?
If it's full, no, it cannot.
No, yeah. Keep it up.
Off.
It falls down now. No controls, right? It controls now. Okay, if I turn it off,
It will fall down.
it falls down,
of course,
right?
yes.
Can you see?
Yes. So the doctor is assuming that we turned off and I started balance to see how the importance of the control, it will fall down. Okay. So
Great.
so it's considered an unstable system. Okay. So of course it will not stay, it will be very difficult to keep it up without a controller. Okay. So thank you.